Okay, now that you guys know the derivative of logarithms, or like how to do them, we're going to use natural log. We can use that to split this up, to make him all different. Okay, so we're going to find the derivative of him. So what we're going to do first is we're going to kind of manipulate him first. The first thing we're going to do is we're going to take the natural log of both sides. Why would you do such a thing? Okay, so natural log of f of x equals natural log of this big hairy thing. Why do you call it a hairy thing? It's nasty. Okay, let's see. 2x squared minus 3. And then you have the square. You know what? I'm going to get rid of that square root. I'm going to make him a power of 1/2. Because this actually works out to be a lot nicer than like trying to do like the product rule inside of the quotient rule, doing the chain rule. Like we have all these rules involved with this if you just try to take it straight. It's possible. But let's see if you guys like the logarithm way now. Okay, so we have the natural log of this big nasty thing. Now there's something you know about logarithms. You can split them up. Whenever there's multiplication and division, you can split them up. So the very first thing that we're going to do is we're going to get rid of this ginormous fraction. Now if you're really good at this, you'd be able to do steps, like a couple steps at the same time. But I'm going to expand it and go into detail here. So the first one, we have the natural log of the numerator, which is x plus 1 squared times 2x squared minus 3. So this is all the numerator. And because it's division, we're going to subtract the natural log of x squared plus 1 raised to the 1/2 power. So it's the natural log of the numerator, subtract natural log of the denominator. And I'm going to go ahead and take that 1/2 and move him down. So piece out 1/2, because whenever you have an exponent inside of a logarithm, you can drop him like that. So I just took the exponent right here and put him in front, so now he's multiplying. And now I have business. Okay, this one I can take the derivative of now. That looks nice. This one, it still looks a little bad, but there's multiplication here. This guy's multiplying to that guy. So let's split him up even more. So we have the natural log of x plus 1. Now we have a 2 right there, but what are we going to do with that exponent? We're going to drop him. So let's drop him right away. So I'm going to put a 2 right here. And we go plus, because they're multiplying to each other, natural log of 2x squared minus 3. Minus 1/2 natural log of x squared plus 1. This equals natural log of f of x. Now, knowing that equation kind of helps now. Remember that equation 3 that we saw? This guy right here? Wait, where'd you go? This guy. He kind of helps. You guys see this right here? The derivative of the natural log of f of x equals this. So when we look at this, what's the derivative of that going to be? If I take the derivative of each side now, say the derivative of that is going to be f prime over x. I'm sorry, f prime of x divided by f of x equals, now we're going to take the derivative of the other side too, d over dx of this whole thing. Now if you're taking the derivative of the whole thing, actually I guess what you're doing is you're taking the derivative of each of these. So if I take the derivative of each of these, what do we get? So take the derivative of that, take the derivative of that, and take the derivative of that. Oh man. So we got, let's see, we have 2 multiplying 2, the derivative of this. Now knowing that little shortcut thing is kind of nice. So it's going to be times the function on the bottom, and then the derivative of the function on top. What is that? Derivative of x is just 1, and derivative of 1 is 0, plus we have 2x squared minus 3 on the bottom, and then on the top we have the derivative of this. So we're going to take the 2, drop him, multiply him to the 2, so we have 4x, and the constant goes away, and minus, this is 1 over 2 multiplying to it, so we have a 1/2 right here. Let's see. Then on the bottom we have 2x squared plus 1, and then we have the derivative of the inside part. So what is that? What's the derivative of the inside part? That's 2x. So that 1 is just useless. So by 1. Oh, and this 2 right here can go up top now. So let's put that guy up top. That's right. You can simplify these 2's right here. Because this 2 is multiplying to this, it's not adding to it, so you're allowed to cancel them out like that. You guys see another one I could cancel? Oh, we can't cancel this. Can't do that. Because we have a -3 on that 2. If we could factor a 2 out of this, then you could cancel a 2. Okay? Thank you for saying that. It's a common misconception. So what does all of this right here equal? It equals this. But we just want f prime, right? I mean, the derivative of f is f prime. That's what we're trying to find. We're just trying to find f prime. So how would I get f prime alone right here? Look at it. We have f prime divided by f. How do we get him alone? Multiply by f. Oh man, this just gets nasty and nastier. So we go times f of x. So that goes away. That means we have to multiply this side by f of x times f of x. Now, to save us from writing, I'm not going to rewrite this whole thing right here, but I'm just going to erase this and write what f of x is. So what is f of x? F of x is that top. It's x plus 1 squared times 2x squared minus 3 all over the square root of 3. No, I'm sorry. X squared plus 1. Oh, snap. So this is your answer. This is the derivative of f of x.